guys, welcome to my channel, Mr. CJ. Welcome to today's lesson about mathematics. We are here to solve some mathematics a bit. So today's lesson is all about matrices. It's a from topic, and we are going to solve some simultaneous equation using matrix formula. The other lesson we were checking on the other two methods of solving simultaneous equation, whereby we check on substitution and elimination. For today, we are going to check on matrix formula. And here is our example for the day. We have 2x plus 3y is equal to 600 and x plus 2y is equal to 350. And here we are going to use matrix formula to solve this for us to get the value of the unknowns, that is x and y. So let's go. So our solution for this, the first thing you should do, you must express the equations in matrix expression. And when I say matrix expression, I mean that we are going to put in a form whereby it is going to be represented in matrix form. That is, you take the coefficient of the unknowns, then you equivalent them to the resultant of each equation. And this is what I mean. For the first equation, the coefficient for x, it is 2, put 2 here. For the second equation, the coefficient of x, it is 1. Then the other side of y, the coefficient of y in the first equation, it is 3. Then the other side, the second equation, the coefficient for y, it is 2. You put it that way. And now you enclose it. Then you open another bracket. X was leading. What was the first one? So you put it here. Then the other known y, you put it here. Then you close. Then you equivalent to you open the brackets. Then you put 600 this way. Then 350 that way. And whatever we have done, we have represented our equations in matrix expression. Now from here, it will be easy for us to solve this simultaneous equation using matrix formula. The second step we are going to follow is to get the determinant. First of all, we must get the determinant of this matrix. So how do we get the determinant? Is the main diagonal minus the minor diagonal, or others they can call it as the major diagonal minus the minor diagonal, or others can say it is AD minus BC. This is what I mean. So our A will be here for 2, so we are going to get the determinant, whereby we are going to say it is A times D minus B times C, or the main diagonal minus the minor diagonal. And that is, our main diagonal will be this 2 times 2, you less 1 times 3, whereby we are going to get it is 4 minus 3, whereby we are going to get 1. And this one we have gotten is our determinant. So that determinant is going to assist us to get the inverse of this matrix, and this is what is going to happen. So for us to get the inverse of a matrix, we put 1 out of the determinant. Then we are going to change some things, or some the diagonals of this matrix we had. So it will be 1 out of the determinant. Then we are going to change the A and the D. We are going to interchange each other. But for our case, they are the same number. That's 2 and 2. So when we interchange, still they are going to remain the same. That is 2 and 2. Then now on the minor diagonal, we are going to change the signs, or we are going to negate. They are a positive 1 and also 3. So when we negate the signs of this, we are going to get negative 1 and negative 3. And this is how we are going to get the what? The inverse. So our determinant was 1 out of 1 into that is 2, negative 1, negative 3, then 2. So when you open the bracket with this determinant, it means you are going to remain with the 2, negative 1, negative 3, then 2. Because it will be 1 out of 1, it is 1. So when you multiply everything in the bracket with 1, you are going to remain with the same thing. Now from here, we have gotten our inverse, that is 2, negative 1, negative 3, then 2. Then our unknowns x and y is equivalent to 600 and 350. Then now there's something we are told here. For us to get the values of x and y, we are going to multiply the inverse in both sides, the left side and the right side. Once you multiply an inverse with its original matrix, we are going to get an identity matrix which is 1, 0, 0, 1. That one you can try and you will get. I've said when you multiply an inverse of a matrix to its original matrix, you get an identity matrix called what? 1, 0, 0, 1. Then we put x, y is equivalent to 600, 350. And we said we are going to multiply the inverse in both sides. So our inverse was this. So we are going to multiply 2, negative 1, negative 3, then 2, the other side. So therefore, already we are done with the left side. So what is needed of us is to get the resultant of the right hand side. And this is what we are going to do. So we have 600, 350. Then it is multiplied by 2, negative 1, negative 3, 2. So here we say we are going to multiply a column times what? We multiply a row. So that's column times row. That's what we are going to do for us to get the value of x and y. And this is how we are going to do it. It is 600 times 2. 600 times 2 plus, so we do plus 350 times negative 3. 350 times negative 3. Then we have our bigger bracket. Then we come to the other side of the row. So it is, we say it is column times row. So it is 600 times 600 times negative 1 plus 350 times 2. From here we can be able now to do what? To get the value of x and y. Now from here we are going to multiply and get, so 600 times 2 we get 1200 plus 350 times negative 3, we are going to get negative 1050. This way, I think you can hear me, you cannot be able to see clearly, but you can hear. Then 600 times negative 1, we are going to get negative 600. Then plus 350 times 2, which is 700. So now from here we can be able to get the resultant of that. And therefore from there I'm going to use this. I'm going to use this side. So from there we have said that from there we have 600. So we add 600. 1200 plus 1050, of course it was negative. Then the other one we had 600, because it was a negative, plus 700. So from there we can get the result. So 1200 minus 1050, you get what? 150. Then the other one, negative 600 plus 700, we are going to get what? 100. That is it. So from here, we have our x, y is equals to the result we have gotten. That is 150, 100. And from there, we can equalize to be x to be with 150 and y to be with 100. And therefore, we can conclude by saying our x is equals to 150 or 150, then y is equals to 100. And that's how we use the matrix formula to get the values of unknown. I'm going to do another example, then now we will be able now to understand it fully on the same. Okay, welcome to the second example on the same. We are going to use the matrix formula as well to calculate or to get the values of the unknowns, that is x and y, of course, the other way around. So we said the first thing you must express the two simultaneous equation in matrix expression, and this is what we do. We are going to use the coefficients of the unknowns. So the first equation that is the first equation with the x unknown, the coefficient is what? 2, we put it that way. Then the second equation, the coefficient of x, it is 3 in that way. Then the first equation, the coefficient of y is equals to what? 1. And the second equation, the coefficient of y is equals to 2. And now we add our unknowns as x and y. Then it is equivalent to 6 and 8. And this is where you start from, or making the simultaneous equations in matrix expression. From here, now the second thing we are going to do is to get the determinant of this matrix, because we have found a matrix. So we must find the determinant. And I said earlier, for us to get the determinant is equals to A times D minus B times C, whereby we say AD is the main diagonal less the minor diagonal. So that is, we are going to multiply 2 times 2 minus 3 times 1, whereby we are going to get 4 minus 3, and our determinant is going to be 1. Now from here, once we have our determinant, we are able to get the inverse of the matrix. So whereby we say, for us to get an inverse of a matrix, it is 1 out of the determinant, whereby we are going to interchange the main diagonal, which is values. So the 2 will come the other side, and the 2 will come the other side. So in this case, they are the same, so they are going to remain the same. So 2, 2, whereby we are going to negate now the values of the minor diagonal, that is 3 and 1. They are positive. When we negate, they are coming negative. So it will be negative 3, negative 1. So from here, our determinant was 1, so that's 1 over 1 into 2, negative 3, negative 1, 2. So we want to get the inverse of it. So when you open the bracket, 1 out of 1 is 1, so we are going to remain in the same values. That is 2, negative 3, negative 1, then 2. This is what we are going to have. So from there, now the inverse we have gotten, we are going to multiply in both sides. That's the left side and the right side. And when you multiply an inverse with this original matrix, I say, you get what? An identity matrix, which is 1, 0, 0, 1, which is x, y is equivalent to, we say we have multiplied the inverse in both sides, that is 6, 8. Then we multiply with the inverse, which is 2, negative 3, negative 1, 2. Therefore, our main thing here is now to multiply this resultant of 6 and the inverse. So that is, we are going to have 6, 8. Then we multiply with the 2, negative 3, negative 1, 2. So we say we are going to multiply, it is column, we multiply with what? The row. That is 6 times, so we are going to have 6 times 2 plus 8 times negative 1, 8 times negative 1, that is. Then the other one, it is 6 times negative 3, they come the other side, it is column times row, so 6 times negative 3 plus 8 times 2, 8 times 2. So you can get the resultant of that. So 6 times 2 is 12, then 8 times negative 1 it is, you get what? You get negative 8, so that is 8. That way. Then 6 times negative 3, it is negative 18, then plus 16. So whereby we are going to get us negative, sorry, that is 12 minus 8, we are going to get 4, and also negative 18 plus 16, we are going to get negative 2. From there we can say x this way is equivalent to 4 and negative 2, whereby we are going to, this goes to this side and this one goes to that side. Therefore, you can conclude x is equals to 4, then y is equals to -2. And this is how you get to know how to solve the simultaneous equation using matrix formula. And you can see how easy it is and how fast you can go to get your 4 marks also. So thank you for watching. Till next time, we are going to do more on the same, and we are going to make your mathematics to be easy. See you next.